Hello everyone, hi. How's everyone doing today? Hope you can hear me. Let's make some tiny adjustments and get going for the day. Okay, I just dropped our check-in link in the chat. I'm actually gonna go back and because I can't hear the music, and then let me lower and get some background music going for you guys. I'll lower that a bit so you guys can still hear me. Let's just throw this on. Hello, hi everyone. Hope everyone's doing well today. If you are in chat and you can hear me, you can feel free to let me know. Feel free to say hi. Today we're going to be doing our. Let's see, I did do that already. Okay, cool. Yeah, so today we're going to be doing our workshop on introduction to GitHub. It's going to be our workshop on version system control as well as security within GitHub. Given that this is security month, we want to make sure we cover some of that stuff. But yeah, let's get started. So real quick, hey, I'm Kev, and I'm a coach at Major League Hacking. I use the he, him, his pronouns. I do a lot of different things, so I generally say you can feel free talking about anything, and there's just some of my information on screen. Hello, welcome to the stream. I'm glad you're so excited. But yeah, we're going to be doing our introduction to GitHub. So schedule overview, we're going to go over what is Git real quick, then what is GitHub, so we understand our fundamentals, and then we're going to look at how we would want to use GitHub normally and why, what applications or what usage cases there is for an application like GitHub. We're going to look at security features built in GitHub. We're going to touch upon them briefly, so we understand, since this is security month, what are there in GitHub. Okay, how would you resolve a merge conflict? We will get to that later. It's pretty simple. But yeah, after we discover the security features in GitHub, we're going to do some hands-on exploring. We're going to set up a replit, we'll go over that a bit later, and we're going to connect that to GitHub. It's going to give us an easy environment for us to do a lot of different things. We're going to set up our own GitHub account, and then we're going to do some demo, and we're going to show you some features within GitHub that will be super helpful as you build any sort of project, personal or on the job. But really quick, what is Git? We'll go over that all when we go over Git commands, as well as how you would do all this in GitHub itself. But yeah, so what is Git? Git enable is a distributed version system control that will allow you to make copies of complete code bases onto different development machines. It's a way to make sure that you can allow multiple people to work on a code at once, as well as allow offline work. For example, you can have your code base in one centralized place. You can think of it like a server, and you would store your code base there, while you would go to the server and you make a copy of that code base on every local machine that maybe a developer is working on, and you would then work on the code base locally. And as you are going through and completing your code, we're completing, let's say, building additional features into your code, you would then push that back up to the server branch, and that way other developers who might be working on the same project can then pull that back down, and it's a great way for collaboration. So Git keeps tracks of changes at the line, file, and directory level, which means that Git will keep track of each line of code that you change. So between different type of iteration of your code, or between as you're building upon your code, you can see what have been changed by who. It keeps a record history, as in if I change something in the code, it would actually reflect that I was the one that made the changes. It keeps track of when they're made. It also allows you to be able to, because it keeps such detailed line by line, file by file, directory by directory track of and changes. It also provides who did it and when it's done. For example, if let's say I made a change on a project we're all working on, let's say me and you are working on a project, I made a change and something went wrong after I made my change, and let's say it broke something. GitHub, because it keeps track of everything, it also allows you to easily revert back to previous versions of your code base, and we're going to go over a bit of that. Git also allows you to do branching and merging, which is that will generate the ability to do parallel development and allow you to code separately without being together. So that means I could be working on a part of the code at the same time you are working on the part of the code, and how we would resolve that is we would create multiple branches off the main code. We're going to have some pictures we're going to look at later, and then off the main code, we would then from there we would then each work on our own part of that main code, and then when we're done, we'll merge them together. And if there's something like someone mentioned in chat, which is merge conflicts, that would be something we would address during that part of the process. So also, a developer can work on features or changes independently, merge it back together to the main code base. Yeah. So a quick overview of what is Git. Git is a distributed version system control system that allows you to have complete code copies of your code base on multiple developer machines. It allows you to provide collaboration and work offline. It will keep track of history for you at the line, file, directory level. It also provides a history of who made what changes, when it was made. It allows you to use tools such as branching or techniques such as branching and merging for parallel development. It allows you to have multiple developers to work on each feature or changes to your code base independently and then join them all together at once. So with that, let's see what is GitHub. You can see that Git is in the name of GitHub. So GitHub essentially is a web-based hosting service for Git repository. A repository we're going to go over later in definitions, but you can think of a repository as a Git instance of your code base. It provides a graphical interface. That's what GitHub does. GitHub provides a graphical interface and collaboration tools for working with Git. It allows developers to create both public and private repository. That means you can create repositories that only you can see. You can also create a repository that everyone can see. And one of the main usages of GitHub is for what we like to call open source development, where we would put code on GitHub, which is open source. So you would make it public, everyone can see it, everyone can work on it, everyone can do multiple things with it. You can help advance the project, you can be able to check and see what the code base looks like, and so on and so forth. It's the whole idea of open source is you can be able to see everything. If you want to make modification, you can make your own version of it, make tiny changes, and so on and so forth. It allows collaborative tools such as forking, which we'll talk about in a bit, pull requests, code review. These are all processes you would normally use as you're using GitHub to ensure a smooth experience with other developer and working in a team. GitHub also has issue tracking system. So it's a way that allows you, if you're making an open source project, to be able to track bug reports, feature requests, and so on and so forth. We'll look at that later. It also has project management too, actually. It's pretty cool. These are some of the newer tools that has been built within GitHub. It allows you, for example, to get like a project board, or some people call it Kanban board, whatever you want to call it. It allows you to create milestones. So you can keep track of how far in a project. It allows you to coordinate teamwork on the repository, right? Because, for example, when generally by yourself, unless you're trying to utilize Git or GitHub's history tracking feature, you wouldn't create a GitHub or a Git repository just for your own purposes. You would generally make it if you're working on, let's say, a hackathon project with a bunch of friends, or a team, or for a school project, and so on and so forth. Those would be the instances you might spin up a Git repository instance, either on GitHub, private hosted, and so on and so forth. We'll look over a lot of that. GitHub also fosters community engagement because it has a lot of social features that allows, for example, developers to follow each other, participate in discussion, have a forum post, and so on and so forth. We're going to look at a lot of these GitHub features as we dive into, take a deep breath. It's okay, sorry. I'm getting a bit excited. As we dive into the exploration part of GitHub, which will be actually making a GitHub account and going through all the different parts and portions of the GitHub. So why use GitHub? Again, we talked about why would you use GitHub. We talked about how when you're working by yourself, maybe GitHub is not the most optimal solution for you. So why use GitHub? So GitHub is a version control system, which means it allows you to keep multiple versions of your code base intact. If you ever need to go back and reference something, if you ever need to keep track of how much work someone's done, keep track of different versions of your code. If you ever doing so also allows you a backup with fail-safe system, right? So for example, if I pushed a new code into we'll draw, you'll see this a lot easier later. But for example, if here is point A of my code, here is point B of my code, I just updated point A to point B and something broke, I can always go back to point A. We're going to break out some graphic and draw this all out nicely. But it also allows for remote access and cloud hosting for code repositories. That means you can host your code on GitHub, which will then allow multiple people to access it. You can access it anywhere. For example, if I'm working on this computer right now, and if I hosted my code on GitHub, and let's say my computer broke one day, I wouldn't lose anything. All I gotta do is go back to my GitHub repository, pull down a new local copy, and the remote copy will be stored in GitHub servers. It's really great if you have like thin, lightweight machines, right? So for example, I might be working on my desktop one day. I go out, I want to work on my laptop. I can still pull the code base directly right down and get going. If you have any question at any time, please feel free to stop me. This is an introduction to GitHub. We want to make sure we address all our questions and concerns. And also, again, there is a huge, vibrant community, especially those in support of open source projects on GitHub. So because how GitHub works, it's one of the biggest online Git repositories. There is a lot of open source projects that are hosted on GitHub that allow you to make copies of it if you want to work on making maybe a tiny flavor, or I guess flavor is what I would call it. So like if you may want to make tiny adjustments to let's say application, and you're allowed to, it allows you to maybe understand the code of application you're using, right? So a lot of open source project on GitHub, you'll be able to see all the code base. You can read it yourself. You can take a look at it. It allows you to make changes to the code base itself, right? For example, if I notice a bug in the code base on an open project, I can go ahead and modify it, work on it, and then submit a pull request, a merge request, and get it all taken care of. So pull it down, I'll push it back up, merge it, and it'll be all great. And then from there, there's also, again, project management tools. So it's great for hackathon projects, team projects, so you don't have to use multiple different applications, right? Some people would, let's say, would use GitHub for, let's say, hosting. And in the past, before they brought out project management tools, you would, let's say, have to use another website or another tool to do project management. But now it's all done in this one nice, neat application, or application, cloud service that allows everyone to access it, work together, and so on and so forth. Code review. So the idea, if you don't understand this, code review allows you to build and process. Let's say I wrote a code, right? When I write a code, I shouldn't be reviewing my own code, because if I code review my own code, everything makes sense. It's, for example, if you read what you write and you read it immediately after you wrote it, your brain can auto-corrects and can complete portions of your writing, right? So it's like you could spell something wrong and not notice it. Code review feature essentially allows multiple users that's working on one repository to be able to read each other code and build in procedures. So let's say if I wrote the code, I can review the code, and let's say Underdog in chat is also working on this project with me. They can read my code and improve that code, saying, oh yeah, this looks good. That helps keep quality. It also allows knowledge sharing and so on and so forth. Because, for example, if everyone else sees that I made a mistake, they can leave a comment and so on and so forth. And we'll dig into all those features later in the session. There's also seamless integration with a wide range of development tools. So, for example, your IDEs. We're going to look at Replit has integration. Everything generally have integration with Git and GitHub generally, because GitHub is one of the biggest online cloud hosting cloud hosting services for Git instances. Then so on and so forth. All this we're going to go over. I'm going to skip the rest of that slide. Wrote that a bit long. So key feature GitHub. Again, we're going over key features. So GitHub allows you to do Git repository hosting. It allows you to use collaboration tools. It does issue tracking if you want to ever work on an open source project. It has project management tool. It has community engagement. It allows it has forums, discussions. It allows you to integrate ecosystem with your IDEs if you're into like JetBrains or like, was it VS Code, or like whatever flavor ID you're interested in. It has security and access control system. It allows you to write documentation and wikis for your code. It also, if you've never heard of it, it's called continuous integration, continuous development. It's a software engineering terminology. It allows you to do that easily. We're going to look at some of that, not in depth though. And it's also a huge open source community. So a few words, if you're new, might have spun you for a ride. Repository. What is a repository? A repository essentially is a database that contains all the files and changes to a particular project. In other words, a repository, you can think of it as an object that is managing your whole entire project. It's your Git instance that is looking at, let's say, all the file changes. That is keeping track of your different commits and branches, merge, and which we're going to go over in a second. But you can think of it as, normally if you code with our repository, here's your code, right? And whenever you make changes, just save directly onto, let's say, the files in your hard drive, in your data. With a repository, essentially that becomes overarching umbrella that will then keep track of your project. So for example, now your biggest thing is a repository. In your repository, you would have your code, right? And your repository would keep track of maybe different instances of those code, as in different history, if you ever made changes here and there, and so on and so forth. Okay, so commit. What a commit is, a Git commit is essentially a snapshot of all the changes you made at a particular point in time. And each commit is given a unique identifier, and that includes metadata. And this is how your repository can tell the difference between each commit. Essentially, how the workflow generally works is you'll create a repository, you'll make changes to the repository, you'll commit those changes. Essentially, it's saying these changes are final, I want to make them. And those will be sent to your repository. Committing it will be first at your local level, right? So when you make a commit, it is currently at your local level. And whenever you're done, we're going to talk about how to get that to, let's say, your cloud level or your remote level. Remote and cloud is the same thing. Remote just means offsite. We also have branches, right? A Git branch is a version of the code that is created from the main branch. So we'll pop out some art after we finish this key vocab and go over the concept real quick of how it really works. But you can think of a branch as, you can think of a Git instance as a repository as a whole tree, right? You have your root or your head, and then you can create branches, which is just a copy of the code created from your main code base / branch. And that allows you to make modifications without altering your really stable streamlined version. And then merge, right? So merge comes in handy it's a process of combining changes from one branch to another. So this is what we're talking about. So here's your main branch. You can think of it as your head, and you can have a lot of split off branches, right? You can think of it like the multiverse, right? Here, if there was one main universe and like there's multiple split, you can split it when you want to do different things into multiple sub universes. And whenever you're done, you're happy with the sub universe, you want to merge it or bring it into the main universe so you can keep those changes in the main universe. That's what merging does. So you have a repository that keeps track, that's a database that keeps track, that actually operates your Git instance, that keeps track of all your changes and all your files for your project. You have committing, which is whenever you're making a modification to a branch, you would make that modification to that branch in that repository, and then you hit commit, which is essentially saying it's like hitting Control S, right? You're saving. And then we'll go over a bit of the other stuff. And then branches are essentially multiple versions of, or a version of your main code base. You can actually make branches on top of branches, but you generally make your branches off your main code base. And we're going to go over a nice little art diagram design of what it kind of looks like. Merging, we've been over, and then a few more simple key vocabulary words with pull request. A pull request essentially will pull changes that may have been made from a branch onto your remote, right? So once if we go back one slide, so once you merge it in, let's say I'm working on something. I'm going to take the two names to see in chat, Claire and Underdog. So let's say I'm working on something. I finished what I was doing. I committed it. I merged it into the main branch. Claire made a copy from the main branch as well, and she's on her own branch. She's working on something. And then she wants to make sure she gets all the code that I made edits to, and I merged into the main branch already. Claire will then make a pull request. What that does is goes from a local branch or a local instance, goes to the remote or cloud instance and go, let me take all that data, pull it right down, and then she will have all that information. So pull request, again, it requests the changes made from one branch into another branch. You have your remote, right? We talked about this instance. I should order these better next time. But what a remote is your remote repository is your main or a copy that's stored on a different machine or server. Generally, your remote repository would be, let's say, the repository stored on GitHub. Your local repository would be the one that you clone down or you pull down from GitHub. A clone, I need to order these better so when I explain them, it makes sense. But yeah, a clone is a process that Git does of making a copy of the remote repository into a local machine, which is then your local repository, right? So if we wrap this all together, we'll create a repository on GitHub. We would then clone that repository down. So my root repository will be on GitHub. The cloned version will be down on your own local machine. Forking is a whole nother concept where if on GitHub, let's say you have where I guess really in anything, but generally on GitHub, let's say you have open source project. Forking essentially makes a copy of that code base and allows you, it creates a complete copy of that repository and allows you to make modifications to the repository as is your own, right? So for example, if I own a repository and I completed, or let's say I built a calculator, and Underdog from chat wants to build upon my work and make a better calculator. Instead of starting completely from scratch, maybe she looked at my open source code, realized she can utilize that. She can make a fork of my project, which means she gets to start at exactly where I left off and just built upon what I do. And that's really useful for working on certain project. And generally in open source, most of the time, you can't directly modify the main project for the main root. What would happen is you would fork the project, make your modification, and then submit a pull request, and someone from who's in charge of moderating, there you go, moderating the open source project would look at your code, see if it's all good, and then merge it in. Pull, essentially where everyone over, pull is the process of fetching changes from the remote repository and merging them to the current repository. It's what a pull request is. There's a different pull request is just their actual request. Pull is what's happening. I probably wrote that. I was a bit late, so at night, so I probably didn't realize I already wrote pull. There's also push is probably what I meant to also write. So what push does is essentially allows you to upload the changes from your local repository up to your remote repository. And then some basic Git commands we're going to look over real quick, and then we're going to look at some of the overall hierarchy structure of it. But some basic Git command, you don't have to memorize all this. We're going to go over them, and you can always look these up, right? It's always okay to look up cheat sheets for things as you're working on them. Generally, no one expects you to have everything memorized. So Git init initializes a new Git repository in the directory you're working in. Git add essentially adds files to the staging area. The staging area is essentially files that are going to be uploaded to your repository. Git commit essentially, again, commits the changes to the local repository. So it's like hitting Control save on a local file. Git status shows everything that is in the staging area and stuff that has been changed. Git push will then push everything from the local repository onto the remote repository. Git pull takes everything from the remote repository, pulls it down to the local repository. Git clone allows you to make a copy of any repository onto a local machine, or a local machine can also be a remote machine. So I'll go over that in a second. Git branch will list all the branches you have in your repository. Checkout allows you to move between branches. Git checkout. Git merge, again, we're talking about it merges multiple branches together, so you can merge from one branch into another. Okay, before we go into security feature, let's actually see if we can get a better understanding of this. Ooh, that's odd. Oh, I don't like that. So I really don't like it when it's fully zoomed in on me. I like this style a lot better, where it's still not fully zoomed in on me. Let me get out our wonderful tool. Now what's funny, chat? I actually was tearing apart my room and realized I have to do a stream, so I had to put together my I'm kind of like reorganizing my room, right? So I like teared everything out of it, including my whole computer setup, and then like I had to scramble to put everything back together to run the stream because I totally forgot. But yeah, so bear with me if things aren't as smooth as normal. Just a bit of work in progress stuff. Let's see, share screen. Select the window. Untitled. I hope this is the correct screen. Okay, cool. Welcome to Microsoft Paint, one of the wonders of the world in terms of explanation. So now we're actually going to go over everything with kind of pseudo topic. Can I do two screens at once? I don't think so. Okay, cool. That's okay. So I will explain everything I kind of did, but in a more graphical way so you guys can see. I'm going to put that in the big screen. So the first thing we're actually going to talk about is what we already went over. I'm going to pull that list back up so I make sure I cover every single thing. So for example, so here is where we're going to start off. Is you can actually make Git repository in multiple different places. The place we're actually going to look at making Git repository is on GitHub. So for example, I'm going to first draw this. So we're going to call this the server, which in our case is going to be GitHub. And this is also known as your remote. Hello, welcome. If you have any questions, feel free to drop it in the chat. And this is, in our case, this is going to be GitHub. This is GitHub, right? And then this is where we're going to make a repository. So when we went over a command called git init, essentially Git makes it all graphical. But if you were to think of this as any regular server, and there was a command line version, you would just do a git init. And what that does is now it creates, you can think of here's like a zoomed in view of the server, right? It creates your initial node. Let's call this your beginning of your repository. So this is when your bare repository. So when you first initialize your repository, bare. So it's gonna say it would make a commit here, which is initialize repository. So here's your starting point. So this is your current start repository, and label it with B. And then I have this here. So then I would then, let's say, have a local machine, which one of the reasons I said local machine actually doesn't have to be local is you can be working on a server. The local machine is essentially just the machine you're working on. That's not the remote. So local machine. So in our case, we're actually going to be using replit. We're going to go over that later. And what this will happen is this will then make a git clone, which is saying go to the remote and make a copy of it on your local. So this is our local machine, and this local machine will then go to the remote and go, hey, I want to clone your remote. And what it's going to do is it's going to then look down here, like, okay, this is all that's in my repository, because, oops, let's take that back. This is the repository, and this is everything that's in it. It will then make a clone of that and put it in here. So what that would look like is now, I'm going to take our arrows back. So now after we use git clone, replit, or our local machine, locally will also have this exact setup. So there's nothing in it yet, it's all empty. So what we would then do is, for example, I want to add a README file, right? If you don't know, a README file is what we use to store all sort of information about your project, about what you are going to need to do to run it, maybe install it, or any questions someone may have, they come over across your code. So let's say I want to add a README file. So this is no longer going to be bare, right? I'm going to erase this. It's no longer empty. Boop, 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 boop. Okay, cool. And then in here, there will actually be a README file. Let me add it. Oops. Oh, I can't see my mouse. Where is it? Oh, here it is. Okay. So now there's a README file, right? And remember, this is your local copy. So it's only your local copy right now. It's not on your actual remote copy. Once a README file is local, you would then run a git add. So what this does is it adds the README file to what we call, again, the staging area. Which then will tell Git, okay, I want to have this file be part of my Git repository. So it's saying, okay, add this file to the Git repository so we can then upload it later, right? And then what we would do is after that is after the staging file, we'll do a git commit, which is saying, look at everything in the staging file and make it final. So before you run a git commit, everything is kind of like, it's like a Word document you are typing in, right? But you haven't hit save. The second you did a git commit, you've saved it, and then this becomes a change in your branch. What happens is this is, let's say, we talk about multiple branches, but in each branch, you can think of it, there's also minor branches. So it would be, when you do a git commit, it will progress this branch to this new location. So we committed something. So you can think of it. So we're going to do two conventions. A big circle is a branch. A small circle is a commit to the branch. And then this is going to be your main branch, which we'll designate with an underscore. So if it's underscored, it's your main branch. And then you can also have sub branches, which is doesn't designate as underscore. We're going to go over a lot of that. Hello, welcome. Have any questions, feel free to ask. We're doing our introduction to GitHub. So we're first understanding Git, and then we're going to explore some of the tools that you have in GitHub. So yeah, so right, we added the staging here, we committed it. So this is all locally. So you can see that our remote branch is only at a B right here. Our local branch has advanced to one commit away. So I'm going to add that C here, right? So that's our commit that we have advanced to. And what we would do next is we would do a git push. Remember what a git push does? A git push will take your local branch and say, I want to upload this to the remote branch. And what will happen then is after you do a git push, if my mouse works, your remote branch would then go essentially, okay, if nothing goes wrong, your remote branch will now reflect this. And let's say I am a third computer, right? I'm going to pull this out a bit so I get a bit more space. I'm going to zoom back in a bit. Okay, so let's say I'm going to scroll down here. You can't see at the top, that's okay. So let's say I get a third computer, right? A third local host. And let's call this chat. So this is chat's local machine. Okay, if you guys, someone's help me out here. If you guys want to make a copy of the Git repository, what would you use? Feel free to drop in the chat. What would you use? So well, this is a clean machine. I want to now make a copy of this Git repository so I can work on it as a local copy. I'm another developer. I'm chat, and I want to make a copy and work on it. What would you use as a Git command? Git clone. Yes, exactly. So we would use a Git clone. Sorry, my handwriting is so bad. I usually have a drawing tablet, but as I said, I kind of scrambled to get my room together for the stream. I was cleaning it, but yeah. So you would use a Git clone first, right? And then we'll clone it down. So when we clone it down, it will look. I need to erase this there, so I'm just gonna delete that. Once you clone it down, you will just get a copy of this, and then voila, here's your Git clone. But what's important now we have 2 users and 1 host. And what it's important now, so let's say now I am chat, right? You guys also wrote something. Let's say you made a modification to the README file, and then you guys committed it. Once you add the file, it knows to keep track of. You don't have to add, or you only add new files. You don't have to add old files. Unless you committed it, so you're at commit sub 2. So you guys also made a commit. And then you guys also use, what would you use if you want to upload it to the remote server? Or Git command chat, if you want to help me out here. Let me throw you on the screen, by the way. If you answer, you're gonna be shout out on the stream, essentially. Well, what do we use, chat? No one knows? That's crazy. That's exactly correct, right? Because we are added it, it's all it knows to keep track of, we clone it down, we use git push. But before we use git push, because, well, I guess I kind of skipped the steps. You're actually 100% right. We use git push, but it's because I already committed, right? So after you clone, you made the change, you first git commit. But because I committed is why this commit increased, right? So I git committed it first, and then you're definitely right. And then we'll use git push. This will now push it directly back onto the server. So what this will now look like is the server will now get replaced by this. We're going to make a copy and just go voila. That's the server now, right? But now there's a problem. So chat, you guys made this amazing update to README, and I don't have it anymore. I'm so local, and this doesn't auto sync, right? So now chat in this remote repository is identical, but me on my replit repository, this is where Kev sits, I don't have that. but I want the changes you made. Maybe I'm working on something else, right? You just made a change to the README file. Let's say I started working on a simple static HTML file, but I want to those update on the README file because I think I want to look at it. I think it's good to have all the changes. What then I would do is git pull, right? So when I do git pull, what happened is it goes to the remote server and be like, hey, is my current branch, is my current local repository equivalent to the remote repository? In this instance, GitHub will go, no, it's not. And when it's not, what will happen is it would say, okay, if it's not, let's merge. Git pull actually incorporates merge. You can do merge manually, right? Merge, all it does is takes one branch and combines it to another branch. Git pull automatically does merge if it doesn't match, right? It would say, okay, well, if it's not, remember what instance I am at, right? I'm currently at this instance. I want to merge all the changes that has happened that I don't have. So git pull will first go, okay, are they equivalent? No. Okay, if it's not equivalent, let me take where I was before, because remember, Git keeps track of that history. And it's like, okay, let me add in everything that has been changed since where I was at. And since I already had all this information, it doesn't just copy and paste it over. It goes, let me merge in with all the changes that has been made to that, and just does that. And kind of stitch together. And then this is then what we replace here. So that is kind of how, right, how git, commit, merge, pull work, right? Working as a team. You can have different instances and still be able to work together. And someone in chat earlier brought up the idea of a merge conflict. The idea of a merge conflict is essentially when, let's say, you, chat, started working on the HTML file, right? And you committed it as commit 3. You work on HTML, you commit as commit 3, but I am still working on the HTML file, right? So you committed it, then you pulled, then you pushed it up. So essentially you were like, okay, let me push that up. And then you took this and it was like, okay, cool. This is now what's on the server. Voila. But let's say I'm also working on the HTML file. Let's say maybe I started it and you didn't know, so you also started it and it's the same name. But the second I tried, let's say, oh, I see you push something new. I want to keep myself in line with the remote. So I go and pull it. When I pull it, it's going to pull down and go, wait, that's not right. Because I'm currently working on C3 as well. But you already have a C3. So what it's going to do, it's going to cause a merge conflict because it can't just merge two things of the same thing together, right? So if there's a line of code and same line, right? Line 1, you wrote def A, right? And same line 1, I wrote def B. That's a conflict. I can't just put this over this or this over this. I don't know which one is more important. So what happens in that instance is Git will tell you there's a merge conflict, and what you would generally do is there is an automated way, so you can do auto merge, which then it will just randomly pick one of what it thinks is the best scenario and merge it. So that could either be taking this one or just replacing this one, or taking a mix of two, and so on and so forth. But generally, in that scenario, what you would do is a manual merge review, and you would just open up your Git merge review, and you look at the difference and pick what you want to keep, right? So for example, I guess you already started writing the basic of the top, and I like your top better. Let me pull that in. And then you would essentially, through a merge review, resolve the conflict, and then you merge it successfully. So that is the idea of working with one master branch and then pulling it locally, right? So if you don't know, we have only been working on one branch, is why you can see that each of these branch has an underscore underneath it, where we're working in the main or master branch. You might hear both terminology. Nowadays, we really call it the main branch. Sometimes we call it production branch if you go work at an actual, as an actual software engineer. It used to be called master branch, but we started moving away from that due to just the connotation between the word master, making it's just not a great connotation. But we're going to clear our whiteboard here. And what we're going to look at is multiple branch development, which is something we talked about being really beneficial. How that looks like is, first things first, I'm going to strip everything. We're going to now go into a theoretical land. I am going to first draw a circle. And this will be our master branch. We're going to call it main branch. Sorry, I flip between those two. Generally, you might see it as master or main. We like to say main. I just been used to it because it's been over Git for us. So this is your master main branch. Give me 1 second, actually. All right, which one of you phoned in? I'm just kidding. Someone phoned in. But yeah, sorry about that. Okay, cool. So looking at this, now you have your main branch, and what it allows, let's say I want to make changes, right? So let's say I'm making commits. So here's my commit on the main branch. Here's my commit 2 on the main branch, right? Maybe I commit 2. Someone wants to continue working on the master branch, but let's say I want to develop a new feature, right? So let's say I am Kev, and I'm currently working on the next thing on the master branch. Generally, you might not work on the master, but let's say I'm working on the master branch. But let's say chat, you guys want to make a new feature. To make both our life easier, what would happen is instead of both of us working on the master branch and having a high chance of having a merged conflict, or just having a high chance of stepping over each other. And let's say, another important reason of using branches is, let's say you want to take out a long time to develop a new feature, but you don't want to impact the main thing, right? So maybe I'm making minor changes to the main product, and you guys are like, I'm so smart. I want to incorporate. Let's call our application. It's a calculator, right? I'm writing the addition code, right? I'm writing the 1 + 1, 2 + 1. I'm writing like the addition, pretend I have to manually write the out, right? I'm making the simple changes, and you're like, I want to add scientific calculator ability, but that will impact our main feature, and I want to continue to be able to progress. So what you would do is you would take out what we call a new branch. So let's call this branch, and let's say this branch is specifically used for scientific calculation. Scientific calculator stuff, right? So science, whatever, can't spell, scientific calculator stuff. So you would take out a new branch from this point, and then you would build your branch, and you commit onto your branch while you work on your feature. And in this way, as you maybe work on this and things happen, the main branch can still be worked on and, let's say, pushed out, right? So I would still be able to go, okay, so the main branch, generally, let's say if you're in a production environment, the main branch is what is going to be deployed to, let's say, a user. So this is what people are going to be actually using. And then I'm going to keep iterating on, let's say, that, right? And then let's say at this point, you're like, okay, I am done with the scientific calculator portion. I want to bring it in. What you would do is you would go push this up, and then you would update your branch, and then later you're going to do what we call a pull request. A pull request is saying, so we know what pull is. A pull pulls locally. A pull request, I guess this is why I probably wrote the both. I think of them as one, but they're two different things, like technicality wise. A pull is when you have one branch, you're on a branch, and you want to go you're pulling from the remote to your local. A pull request is saying, hey, I am now done with this branch. I want this branch to be pulled into this branch, and all the features from this into this. And what that is going to do is it's going to say, okay, you're done with this branch. Okay, cool. Let me put everything you worked on here and here. So now it will have everything that I've worked on. So after this is done, what it will look like is this. It will create a new commit on the master main branch, and it would have C3 and C3. So it will combine both the feature from your scientific calculator branch as well as my branch and make it into one. Okay, that is overall a really quick overview of what you can possibly do in GitHub and how everything kind of works. Is there any questions before we pick up where we left off and before we go into the demo portion of our day? Of our workshop, I guess. But thank you, appreciate it. I try my best. If any question, I would love to address them. Git it can seem really intimidating, but it's really not. I would say what you want to do if you're new is you can create a local Git instance and just use it by yourself. Because once you get good at it, you can start using it with other people. Any other question? I wouldn't say it's a great explanation. I'll take the good explanation. I can definitely do a lot better. There's definitely a lot of refinement. But yeah. If there's no questions, we're gonna look at, so because this is security week, we gotta look at what makes Git secure or GitHub secure. Like you have Git already, right? Git you can use locally, right? If you ever end up hosting your own server, you can host your own Git instance there. So why would you want to use GitHub, right? We talked about some of that already, but what more? We have the security aspect of GitHub. GitHub allows two-factor authentication, right? That means no one can just hijack your account and steal it. Realistically, that won't really happen with a local server either, right? But this is something one that's hosted on the cloud. It has two-factor authentication, allowing you to. I'm really glad to hear that. If you have any questions, feel free to ask. I hope because you said that, I want to clarify real quick. Pull request is generally when you take two branches and you merge them. Where you take a branch and you pull it back into the master or main branch. Well, a regular. So there's two pull requests, right? That's a pull request, and then you also have a pull request, which is you're pulling from the remote to your local. Both of them, I'm pretty sure, both called pull requests. If I made a huge mistake then, because I could have not remember the branch to branch thing, but no, I'm pretty positive. But yeah, I'm glad that helps. But yeah, so it allows two-factor authentication to secure account, so no one can just hijack and take over your code base. While you're working on, let's say, remote stuff and working with other people, you have secure access control. And what that means is allows you, the repository owner, so if I own the repository, to manage access permission, right? That I can I can create teams and only people in certain teams can view it. They can choose who can view the code. You can choose who can actually contribute to the code base, who can actually modify the code base, and so on and so forth. You get a lot of actual ability to control who uses the code base, who uses the repository, and what they can do. It provides code scanning. And what that means is GitHub will actually scan your code to identify potential security vulnerabilities, and it will provide analysis of it. And it would tell you, let's say, oh, here's a really common coding mistake, or here's a known security issue you might want to fix. It does dependency insight, which means GitHub will look at all your dependency and the version you're using and highlight vulnerability in your code. And this is really important since developers, generally, you don't write everything from scratch. I might use a library, and without me knowing, the library might have had a security issue at the version while we're using it, and then they push the update. It'll let you know. It'll let you know you should probably update, and so on and so forth. I'll show you an example of it in a second. It also does security advisories, which means it allows developers to create and receive security advisories, notifying, let's say, project contributor and user about any particular let's say, vulnerability or threat and in your code base, and then it will help provide guidance and remediation. This is essentially really big for like open source community and so on and so forth. You have security alerts, which is GitHub will automatically actually scan your repository, look for vulnerabilities in open source dependency, and send an alert to the repository maintainers for them to address these vulnerabilities promptly. And this means, let's say I have an open source project and you might be using part of it. It will let you know that needs to be addressed, and then it will let me know it's been addressed from, let's say, me to pull what you fixed. It also has sensitive data detection. We all know, if you don't know this, here's a really good big thing when you're working with repository, especially when you're working with a repository that's not local and online. Do not ever put your API keys directly in your code base and publish it. What that you do is you can never scrape that clean. You can try, but you cannot, because remember, it keeps track of every line, every history. So the second you accidentally publish your API key or your security key or your encryption key, so on and so forth, that becomes public information. You can try to revert from a Git thing, but your revert also is kept as a history. So once you publish it, essentially it's out there forever. But because of that, GitHub has sensitive data detection, where GitHub will identify potentially sensitive information. So it's like if you're putting a password into your code, maybe you need it, there's proper ways of storing it, like or talk about it in a bit. But like if you put your API keys and you try to commit to a repository, GitHub will actually recognize, hey, are you sure you want to commit this? This doesn't look like something you want to commit and publish and have everyone be able to see it. And that's a great security warning thing, because you never really want to publish your passwords now. On top of that, It also provides audit logs of user activities, right? So you can be able to see who modified what, who might have tried to change parts of the code, who might have created a branch, who might be performing actions on the repository. So you also not only have access control, you also have audit logs that you can still keep track of whoever has done anything in the access control and be able to keep track of all of that. We have access control token, access token management. What that means is you're allowed to generate tokens when you're authenticating with, let's say, the GitHub API, and allows you to control different parts of the project without giving out certain information. So there's also GitHub, so security key generation, right? So like SSH key gen, if you know what that is, you generate a secure key to help communicate between servers. That way, let's say that computer is the only computer that can make modification to the code base, right? So instead of going off of, oh, it's on login, all you can do is you can say this computer is allowed to modify this code base and only this computer can, because there's a key that's in this computer that matches with another key on setup on GitHub, and it will identify and be like, oh, these two match, so you can work on it, and so forth. You have security policies, and this is really important, right? As your project gets bigger, well, when you start working in actual software development or software engineering roles, we have things such as security policies that allows you essentially to enforce certain things. For example, branch protection rules, right? Like no one can ever merge. So if I'm working on an open source project, there's probably branch protection rules on who can actually merge into or make a pull request and then merge it into main or master, right? That's your main branch. So that's like the most stable branch, and you wouldn't want everyone to be able to merge into that, because then you're destroying it. You have no quality assurance of the code base. You have no way to keep bugs out, and so on and so forth. You can also do security policies, right? For example, 2 people working on this project have to code review your code before you're allowed to merge or we'll create a pull request, right? Once you create a pull request, 2 to 3 people that are the authors on this project have to look at it before you can pull it in. Merge it in, whatever. So there's a few things as you work, if you ever get to it, work in teams, we might use some interchangeable words, but the general idea is there. If you're confused as I'm doing it, I do apologize. I'm just a bit used to it. But yeah, those are generally some of the security features that are offered through GitHub and why they're amazing, right? So it allows you to keep your account secure, it allows you to keep a code base secure, it allows you to notify of not only keeping your code base secure from other people, it allows you to notify vulnerabilities within your code. It protects you from publishing sensitive information. It allows you to set up processes to make sure there's quality code and there's quality assurance on your code base. It allows you to alert dependency issues, right? So you might not be staring at every dependency, but GitHub is doing it for you. And here's a good example. Here's a GitHub email I got. I hope I didn't leak any information. I checked, I think. But yeah, so this is GitHub, just security alerting me saying, hey, this personal project you have has a few vulnerabilities. It also tells you the CVE, which if you don't know what a CVE is, a CVE essentially is an identifier for security vulnerability or flaw. And what CVE stands for is, I can't recall. Let me look at that up. It's Common Vulnerability and Exposure. So every vulnerability is assigned a CVE number, and that way is how the security community will be able to keep track of everything and knows that what we're working on, right? So as soon as a new vulnerability is discovered and someone submits it, it generally gets assigned a CVE. It's a unique identifier for that vulnerability. So you can see that in this example, not only did it actually say what version it is outdated on, it tells me what version I've updated to. It tells me why. It tells you what library it is. It tells me the CVE that the CVE number. So if I want to look more into this vulnerability, it also, if you see, it tells me how severe this vulnerability is, right? So there are some things that are more severe than others, right? So if it's something like, oh yeah, this library has the ability to print out an extra one, right? It's kind of like whatever, so on and so forth. But if the thing is, oh, this library now allows you to inject code into your project, that's super severe, and so on and so forth. It tells you the severity. You can do more research. It's a great tool. Really good. I bet you many people doesn't know about it. A lot of these security features GitHub are continuing to add and develop, especially like the sensitive data detection. These auto scanning of GitHub, it becomes really popular with automation and security. Yeah. So let's get set up. We're actually gonna not set up Replit first. We're actually gonna start demoing GitHub because I don't know how far we're gonna get, and we already went over a lot of examples how to do it locally. So we're actually gonna look at how to use GitHub. So I'm actually gonna now switch my streaming again. Whoop, toss that out of the way. Stop sharing that screen. I'm gonna start a new share for a new screen. And this might go away for a bit because I'm going to be making a new account with everyone. So if you do not have a GitHub account, make one. If you do, amazing. So what you're going to see right now is this says GitHub. So if you go to github.com, let's build from here. If you don't know GitHub, if you aren't aware, there's something called AI nowadays. It's getting pretty popular. And GitHub Copilot is their essential AI pair programming thing. I don't recommend you start with that. I recommend you actually know your stuff before you have Copilot, because Copilot can also make mistakes. It's good to have to be able to check your own code and so on and so forth. On top of that, it's not always free. As a student, you do get parts of it for free. So if you want to look into that, you can look at the GitHub Student Pack. Those are a great tool. GitHub creates a student pack with more than just GitHub tools. They partner with multiple technology stacks and brands to bring in this amazing toolkit of things that you can use as a student developer. But you can look that up. It's called GitHub Student Pack. But for right now, we are going to be creating a GitHub account. So I'm going to sign up for GitHub. While you look at me sign up for GitHub, so I'm going to do whoop. If you already have an account, feel free to sign in. I'm just going to sign up for GitHub right now. In case it's really just for people who haven't signed up, I want to sign up with you. So first things first, you just type in your email, right? Let me do that. Let me do that. Okay, and then you create a password. Let me make sure that's correct. Okay, so I'm gonna create a quick password real quick. If you have any questions, feel free to ask right now. I'm just making an account. If you don't have an account, go come make one with me. Enter a username. From form. I always get those two mixed up. From is F-O-R, no, form. Oops, did I mess that up? I might have messed that up. I want to do from. Yeah, that's right. Okay. I always get from and form mixed up. No, I really don't want product announcements. Solve a puzzle. They also made this pretty cool. So now you can now it's like a form you fill out, and it's all cool and animated and stuff. Used to it was just a plain sign up form. Pretty cool though. Making this account, just give me 1 second. When it's made, we'll show you. I just needed to do this from scratch so everyone can see. So once your account is created, it sends an email. I should have seen this one coming. Welcome to GitHub. Welcome. Whoa. Okay, cool. Is everyone caught up? Does everyone have a GitHub account before I continue? So you can say just me, student, and ask you some questions like that. I think I can start sharing now. If I leak something, oh well. It's oh, what speed feature are you using, right? We talked about some of these features. You can see they're selling it to you. You have collaborative coding, automation and CI/CD, security all the way, right? This is all we kind of talked about, right? Secret scanning, code scanning, dependency graph, dependency alerts, enterprise security level stuff, right? Like LDAP, API, IP allow list, so on and so forth, right? Well, I'm super interested in using that, right? You have collaborative code stuff, code spaces, but I had just done this, right? What was I doing? Why did I create I did not know they made this so cool and so helpful now. This didn't exist before. I'm telling you, this is new. And I also, my GitHub account existed for a while. I've never seen this. But this is awesome. It's straight up awesome. I'm interested in everything. Client application, project management, team administration, community. This is just, it just did it for me. I don't even know why I made my slide. I should have just pulled this up. But yeah, you can see everything that you're allowed to do. And then we're just gonna hit continue. And then it's like, oh, here's what's free. Here's what you need in Pro. The GitHub Student Pack allows you to have everything here. Oh, it also gives you GitHub Pro for free as a student pack. I'm not going to activate this only because I have the student pack active on my main account, so I can't get it here. So I'm just going to create the free version. But if you are a student, you should make the GitHub student pack. Whoa, they really upped their game. That looked like a whole game. And they show my dashboard. Welcome to GitHub. So this is GitHub. We're going to first create a repository. Is what we're kind of talking about, and that's where we want to start, right? When you first start by making a Git repository. So I'm going to make my first Git repository. I'm going to hit create repository. So I'm the owner, self-explanatory. I'm going to switch up the music track. I forgot that I put on for you guys. You probably listen to the same music for the past forever. I'm going to start a new music track for you guys. There you go. Then, as I do that, actually, we're going to take a short commercial break. I'm going to be right back. Please bear with me. It's going to be a 5-minute break. I'm going to go get something to drink. Been talking for a while. We'll be right back. Don't go anywhere. It's going to be super fun. Do not leave. And we'll be right back. Let me see. There we go. Okay, we're back. Welcome back. So I don't know if you guys had. It's called like Chi Forest. It's pretty good. It's 0 calories, sparkling water. I just happen to have one around. It's like get the energy kicking and going again. Okay, cool. So we talked about the different type of repository we have, right? You know, public repository and private one. Public ones everyone can see. Private one only you can see. This is the level of security control, right? There's some code base. You might be working on a personal project. You don't want it so everyone can see. And if I'm not wrong, and if you can still do this, I'm pretty sure you can switch between repository from public to private and private to public. So you might want to start a repository as private, work on it for a while, maybe. Oh, now it becomes open source and you can public it. How long is the session going to last? We'll be ending shortly after we explore some of the features of GitHub. It's generally a 1 to 2 hour long session, but it should be not too much longer. But if you ever gotta go, feel free to go. There's always going to be a recording, which you can pick up where we left off on the recording, and just continue to look into this yourself. But yeah, so we're going to make a quick repository. I'm going to speed it up a tad bit, only because you're right. It's been like an hour and 10 minutes. So I'm going to write global hack week security test, right? So we're checking the availability. Okay, that's available. You don't need to make it private. I'm going to add a README file into it. Git ignore template. What that is it's telling to ignore certain backup files for certain application, right? So if you code in certain programming languages, there might be a lot of MISC file that you really don't want your Git to ever pull in. What git ignore does, it's saying, oh, don't ever add those files. So like there's some files that is only local, specific to the application, and you don't want them to pull up. And programming languages don't have it. You wouldn't see them listed here. And for example, if I'm working in Python, there might be certain Python files, right? Like the, let's say virtual environment that might be in your same folder that you don't want to pull up. So like I would do Python, Python, right? And I'm gonna add a git ignore for Python, so it knows that. Your license, it really doesn't matter unless you're working on open source project. We're going to put no license. We're going to create this repository, especially if it's private. Now the project has been created. This is what the repository looks like, right? It's a really nice, easy graphical view. If we were doing this in command line, we know the command will be git init. You can see that it says initial commit. Remember what we talked about. The second you make that first git init, you create an initial commit. And this commit is just empty. Well, for us, it's the git ignore in the readme.md because I asked it to add it for me, but it could come in empty. So like here's the readme, it has a simple title, and we can see here is the cool things in GitHub, right? We have our code, which is essentially we can keep track of all your branches, and you can, if you want to look at branch, you click on here. You can see these are all your branches. The only one I have right now is main, and GitHub allows you to do all this from a GUI, right? So let's say I want to make a new branch, right? So I want to make a new branch. So my main might be, this is, let's say a calculator app. Maybe I want to make a new branch called add, let's say mult. So I want to add like a multiplication feature, but it's so complex, it's not. I'm going to need to make a new branch. I can hit enter. Or maybe I am trolling. I am pretty sure this is supposed to work. Git. Oh, I was supposed to hit the thing. So I'm going to do add mult, and then you could go down here. I don't know why I hit enter. And then you hit create a branch. What this says, it goes from the main branch and makes a copy. So right now, if you can see, if I click on this, you can see that there's two branches now, right? And it says, here's my main branch. And then in the main branch, after the main branch, I have add mult. And see, it even knew that, right? Because everyone knows generally when you use Git repository, it knows you want to protect. So here's a security feature it's telling you. Your main branch isn't protected. Protect this branch from being pushed or deleted. Because if you don't, someone can delete this branch. So I can do is it even reminds you. You can just all you got to do is hit protect this branch. And what this does is allows you to say, let's say, requires a pull request before merging. So no one can just merge directly into this, which is really important, right? You can say the number of approval you want. This is a security feature we're talking about. So branch protection. So maybe you need 6 people to approve before you're allowed anything to be merged in. And this is especially important. That's especially important for projects that are bigger, because there might be a lot or open source, right? You can have like this stale pull request, and when new commits are being pushed, which essentially means like when something has that has new things have been made changes to it, it won't allow. So it requires code read from code owner. This is something that's in pro, but you can see there's a lot of security feature, right? Required a signed commit, which means like you need to sign your information into it, right? You can commit without signing information. It's like a signature. So the second commit is you can always commit. A signed commit is essentially just you committing, but you would tag in, let's say, your name, your email address, so on and so forth. Like I say, maybe I want everything to have a signed commit. I shouldn't drop some of this stuff because I'm going to be showing you some stuff and I really need that. Require learner history, right? That means you cannot merge branches that are offset. What that means is, let's say, here's my main branch, right? When I made the let's say feature branch, I made it here, and let's say my main branch went all the way to a head. Your feature branch won't be able to merge in because it requires learner history, which means you have to first get your feature branch. You need to merge the main into your feature, then your feature back into main. So that makes sure everything is streamlined and helps prevent merge conflicts or issues where there's a lot of conflict in your code base. And so on and so forth. You can see this. There are just a lot of protection rules you can put in place, and that's in settings. If you want to do it manually, that was like our hint that you should do it, right? You can always go in setting and go to branches, and this allows you to add branch protection rules for any branch. Some companies or some development places where if you're working as a software engineer, they might have 2 branches that are protected. One might be called production, which is the branch that has actually the code base that's being used or sent out or deployed into production. You have maybe one called main, which is where the branch everyone's working on, and whenever that branch is done, it will get uploaded to production, and production will then get deployed out into the real world for someone to use. So we have our code. We showed you how to like create branches. You can add files directly up here, right? I can create a new file even. You can honestly code in complete in GitHub. I think they even started adding some IDE features and stuff, right? But like I can do like test file and then like do edit, right? I'm edit mode. I'm like hi, and I can do commit changes, right? So remember what we said. Commit changes, what it does is it actually is essentially saving these changes onto this branch. So I just saved it. I just commit the change directly to the main branch. So if I go back here, you can see the main branch has test file. But here's a really important thing. If we look at our feature branch, you can see it doesn't exist. And it tells you it's one commit behind main, meaning main has made one more commit from where this feature branch was based off of. So main's now here. Well, I guess here, right? And then the feature branch is like here. But yeah, and then we can also look at things as issues. This is what we're talking about. You can create new issues, right? So if you're working on a team, you can create labels for your issues as well, right? So we'll think of some label already. So bugs, documentation, duplication, enhancement, good first issue. So for example, I want to create an issue to say, yeah, you guys should. You can assign it to people as well, right? So I'm the only one working on here. So let's say I'm assigning it to myself. I'm labeling it as I need enhancement. So I'm making a request for a new feature. In this project, right? I don't have a project called, I didn't name a project. I'll show you how to add a project in a second. And I'll show you how to add a milestone. But let's say add a div feature. So I want to be able to divide. So I'm going to tell it I want to add a div feature. And then I'm going to be like, hey, I want a div feature. And then I'm going to hit submit new issue. It's just going to put it to the issue board. So like if you're working on a project, it's really helpful. It's been, oh yeah, someone wants an enhancement feature that does XYZ. I actually used a lot of this as project management for a research project, or not a project, like a research lab. And I was like managing the whole entire project, and we used a lot of this type of stuff. So here's your pull request. Remember, there's pull request and there's pull request. There's pull request where you go from remote to local. There's also pull request where you combine 2 branches. But yeah, so you have this. Here's where you make pull requests, right? So let's say I want to make a new pull request. You say what branch to what branch. You'll say I want to add from this branch into main, and then this is nothing has changed. It wouldn't let you, but it'll say compare this branch, looking against main, and then we'll pull this branch into main and merge it through. You have actions. Action is part of the CI/CD pipeline. This allows you to do continuous integration, continuous development, continuous integration, or continuous deployment. CI/CD. Why am I saying it's definitely continuous CI/CD, continuous integration, continuous deployment. So it allows you to be able to do that. So continuous integrate into your project and continuous deploy it. So there's no downtime. And you can see you can deploy to multiple things. GitHub has a lot of this built in for you, right? Continuous integration, continuous deployment, automation, and so on and so forth. But this is where everything is heard on action. Project is what we talk about, some of the project management tool. Well, look at that. Jump right in for now. So what you would do is, first you'll go to project. You'd be like, well, there's no project yet. So you would link to a project. There's nothing. You just create a project. So I'm going to create a project, and this project, maybe I would call it, jump right in. So untitled project. I'm going to hit create. And you can see that this creates this whole new, you can have multiple reviews, but this is essentially, you can turn to whatever. So this is currently as a task list view, right? So let's say add div function. I'm gonna hit enter, right? Now there's a task. I can assign it to someone. I'm the only person here, so I'm gonna assign it to myself. This allows you to do project management, add a new view. So maybe like board view more than a table. you can then move it through like a normal Kanban board, like, oh, this needs to be to do, right? So I can move it to do. Oh, this is now in progress. I'm working on this. I am done with this, so on and so forth. So from that, we're actually going to go back to the GitHub repo. So I'm going to go back to this repository. And then we looked at our project, right? So I kind of just currently added project, I updated it, and so on and so forth. You have security, which will then look at your actual code base. We talked about some of this, right? So like security advisory, you can look at those. You can enable a dependency bottler, which will then tell you about what I kind of showed you if there's dependency issues. You can also do code scanning, security policy, which is how users should report vulnerabilities to you, advisory, so on and so forth. This is all the security things we kind of looked at. If you want to ever look more into that. Insight, I don't have this, but if you you can enable it. But essentially, once you enable this, it'll keep track of what dependency looks like, your code frequency, your commits, your pulse, the number of forks you have, and so on and so forth. And then we have settings. So what's important is you can add collaborator, right? We talked about working with other people. This allows you to add collaborator and be able to work with them. You have branches, right? We talked about how to add projected branches and so on and so forth. You have tags that help you to keep things organized. This is for Teams Pro, whatever. You wouldn't need that really, to be honest. You have rules, which will then actually, if you do a branch rule set, it will tell you, let's say, how to enforce certain things or how to bypass things. This is really advanced. I highly doubt most of you guys will ever get to that point of using. We talk about actions, right? This is what allows you to do continuous integration, to deployment, and so on and so forth. It's what we call workflow. Webhooks, if you know what that is, it allows you to utilize webhook, and then you have code spaces, which allows you to do set up pre-built configurations for it. Pages, this is really important. So what Pages does is it allows you to actually create a web page for your repository. So you're essentially hosting a website from your repository, and you can do all sorts of things on it. So you might use the Pages as a blog, you might use it as documentation page, and so on and so forth. We have security analysis thing again, and then we have your deploy keys. This is what I was talking about, is you will use a deploy key for deployment and stuff. You have your secrets. This is where we talked about how you don't want to actually publish your secret. What you would do is actually store your secret here, and then you store a variable within your code base that matches up to the secret, and then your code will be able to be like, instead of going, oh, it's hard coded in, it will go, oh, here I need to grab the secret. It will go into the backend, grab the secret, and utilize that, and so on and so forth. Cool. Yeah, that's really everything about GitHub. Is there any questions from anyone? If not, we might actually call it a day for today. We got through a lot. I guess we didn't get through some of the manual Git stuff, but this is a GitHub workshop. Next time we can do another Git workshop. We can go through the manual usage of Git. Is there any question from anyone? I'm super glad to hear that. Again, GitHub is amazing. I am glad you guys stopped by and learned a lot from GitHub, about GitHub actually. Any question, it could be about GitHub, could be personal question. I would take anything. Ask me anything. For sure. I'm glad. Oh, I forgot to change the bottom. If you're still around, you haven't checked in, you do want to check in. Checking in is great. It's good for you. It's good for me. It gives me data to figure out who, what events are popular. And with that being said, please do stick around for detecting fraud with machine learning, held by Will. That's happening in 40 minutes from now. I also do want to push, if you want to come back for another my stream, I'm going to be doing Cybersecurity 101, building a foundation for digital protection, which talks about personal security and all sorts of security vulnerability risk. This is Eastern Standard Time, because this is everything is done. So it's going to be on Thursday, June 8th at 8 p.m. Eastern Standard Time. If you're interested in learning about some cybersecurity and personal foundation stuff, please do stop by for any of that. If you have not checked in, I'm going to drop the check-in link in the chat one more time. Just in case you haven't checked in, make sure you check in. Outside of that, I highly encourage you guys to stick around and enjoy the rest of the stream and stuff, you guys have a global hack week. And for now, I would say goodbye. Let me do this. Wait, stick around for... Wait. Don't go. Stick around for... I gotta edit this real quick. Stick around for this with Will. Save. There we go. Stick around for detecting fraud with machine learning, part 2 with Will. Yeah, for sure. So you can find that a lot of these recordings is generally going to get uploaded to YouTube later on. You can also look for these recording in the VOD section of our Twitch chat. These are always great to catch up on. For sure. If you can't make any of these streams, it's okay. There's always VODs to watch. There's also the full schedule on Global Hack Week. Schedule.globalhackweek.io, so on and so forth. I forgot the URL, but yeah. I should know that. Actually, let me check. It should be schedule or global. It's globalhackweek.mlh.io. I knew that. And it's /schedule. So if you want to check our schedule, globalhackweek.mlh.io/schedule, and you can see what's coming up right after. I will be back for day 4. We're talking about Cybersecurity 101. If you're missing that, I will also be back on day 5, I think, actually. It might be a back-to-back one. Yeah, day 5 on Malware 101, which will go understand and protecting against malicious software, which would be all super fun. A lot of fun stuff coming up. But yeah, outside of that, I wish everyone a wonderful rest of your day and hope you guys have a wonderful Global Hack Week. Now, take care. Thanks for stopping.